Hi guys, I'm going to talk through the Unit 3 lesson plan today. One thing that I think we need to keep in mind about Unit 3 is that it's the entire quarter 2. We're going to wrap it up with CA2, so CA2 is going to be almost all of triangles and trigonometry, Pythagorean theorem, things like that. So that's one thing to keep in mind, which is why because the whole quarter is one unit, it's broken up in the middle with a mid-unit test. Okay, so that's just one thing that's unique about quarter 1 from quarter 2. All right, so starting to look at it, we have a global context of personal and cultural expression. The key words that I pulled from that are artistry, creation, and beauty. Because of the project that I have for Unit 3. It's an Art of Triangles project. So I thought the personal and cultural expression would work very well. The key concept is going to be logic. I chose that primarily because triangle congruence is a big thing in this unit, and we need to use logic to explain why two triangles are congruent, or why they're not, or why two triangles are similar and why they're not. The related concepts are justification and equivalence, kind of going along with what I just said about similar triangles, congruent triangles, justifying why the hypotenuse is the hypotenuse, etc. Statement of inquiry is logically justifying equivalence can enhance creative artistry. That's a combination of the global contexts, the key concepts, and the related concepts. So that would be an interesting statement to explore with your scholars, or change up a bit and explore them with your scholars, so whatever you think that your kids would get into the most. All right, so going back down through the unit plan, we have some questions. You can go through the factual, conceptual, and debatable questions on your own. Please emphasize the debatable questions here. I think because this is such a long unit, it can get pretty heavy and dry for the kids. But if we start looking at some of these debatable questions, the kids can get into the lessons a whole lot more than if we didn't ask them. You guys can go through the content on your own. I don't really want to talk about that right now. So I'm going to zoom down. Interdisciplinary connections. So art is a huge thing in this lesson. So I love art personally, which is why there's so much art built into this unit. So I talked about how you can create works of art using Lego pieces that, when standing far away, look like a perfect picture. But when you look closely, you can see how it's pixelated. You can see the individual pieces of Lego that create such a beautiful image standing far away. And so that same idea we're going to get into in the unit project. But that's something to consider, is that this beautiful parrot is actually made up of square-shaped Lego pieces. You just can't tell that from a distance. Here's another example. Images can be blurred or pixelated. You can tell, or hopefully you can tell, that this is Van Gogh, which is kind of a cool thing because it's extremely blurry, but it's such a well-known image that even when it's blurry or pixelated like this, we can still recognize it. History, it says there's often several ways to solve a problem, so that's why in history we see how various cultures or countries have argued over treaties, laws, etc. Similarly, in class, when we're looking at these triangle problems, there's multiple ways to solve the problem. You can use Pythagorean theorem or trig or special right triangles sometimes in these problems. So it's good to emphasize to the kids that there's not always one right way to go about a problem. You can get to a good solution via multiple methods. And I think that the scholars have a hard time with that in math, because I think in the past they've been taught that you do math one way, or you multiply one way, or you solve equations one way. So I think geometry is a cool opportunity to show the kids that math can be very creative and there are multiple ways to get to a single solution. The performance task is, there's a Pythagorean theorem investigation that is on Blackboard. The Art of Triangles project is the big project that I've been referencing already. That's on Blackboard. Using trig to find the height of your classroom or the building, that's criterion D, so it's a real-world application. With that, I built it into one of the lessons, but you you might not have time for it if you spend a lot of time teaching the other things, or if you take a day to split a lesson into 2 days. And so just be careful with that. If you want to use that project, then you're going to have to squeeze in the time for it. I highly encourage you to. I've done it before. It's been cool to see that the kids are using tools in the classroom, working with each other to apply geometry to finding the height of a classroom. It's pretty cool. I'd suggest using it. There's a mid-unit exam, and then criterion A is your common assessment. I want to talk about the Art of Triangles project. The whole thing about this project, it's quite long. You're going to want to break it down into several bite-sized pieces. So on the back of the project, the last page of the project, there are checkpoints that you can give due dates for. You can say like page 3 is due on the 2nd, and your essay draft is due on the 15th, however you decide to do it. But because we primarily work with freshmen, and even if you work with sophomores or 8th graders, like they're still at the age where they should be responsible enough to meet deadlines, but they need help with time management. So please give them the checkpoints because the project is so long. Okay, so the project is creating an original piece of art using only triangles. And ideally, their artwork would not include space, like all this white space in the middle. Ideally, their artwork would not include that white space. But I pulled up examples from Google just to give you an idea of the types of things that I look for. I've given this project a few times before. I love this project, and the kids really embrace it and come up with very creative things that are personal to themselves. So I think it's a good expression tool for us to use with our scholars. So here's one. I like this. It's extremely detailed and in-depth, but I like the way that it's using triangles and different values of color to show depth and highlights, things like that. Here's another one. I've seen something like this a lot more often where they create an animal out of triangles. I've seen a panda or a dolphin or a bird or a lion. I've seen lots of different things, and the kids really like it a lot. And I always ask them why they chose a lion or why they chose a panda. And it's interesting the responses they come up with. This one is interesting because it's quite geometric and it's quite abstract. It's all triangles, but some of them are filled in differently, and some of the triangles are bigger than others. I think this one is really cool if a scholar is maybe more methodical than others. This is very detailed. This one is cool. I looked at this one and I thought about whether I would take it or not because the shapes are like triangles, but they're not filled in. But I looked at it as like the shapes are triangles, even though they're just lines that create triangles. Whereas in something like maybe this, the triangles are all filled in, so it's more obvious that the whole image is made up by smaller triangles. I would still take this because it's still creative. There is a high level of detail that it involves planning, use of color, etc. Going back to the unit plan, this is the rubric for the project. This project is only going to fall under criterion C because it includes an essay and a presentation. I think it's a very big project that you should sell pretty hard to the kids so that you get quality responses. The first year that I did this project, the presentations ended up being a pretty big disappointment because the kids weren't as sold on the nature of the project. Like, it's extremely personal and very expressive, and if the kids don't understand that they're allowed to be personal and expressive in math in a project like this, then I don't think they're going to be. So please sell this on to them, that this project can suit them and their personality quite well. All right, moving on from that, if you guys have questions about the project, then please reach out to me. It's my favorite project out of the whole year, so I would love to talk more about it. Here's the criterion D for the trig, for using trig to find the height of a classroom. You can read through that on your own. This unit is so long, so there are a gazillion learning experiences and teaching strategies here, along with differentiation. There are lots of different creative ways to teach triangles or to teach what a leg is versus a hypotenuse. Learning that the biggest angle is opposite from the biggest side of the triangle, things like that. Lots of different creative ways to do this, so please read through this. And if you need more ideas, then reach out. I'd be happy to give you more ideas because I've tried many throughout the years. Or if you see an idea that's not here that you'd like to share with everybody, then please send us all an email and share with us. Let's be collaborative here. For the formative assessments, there are exit tickets within this unit plan. There are quiz prep homeworks and mini quizzes. Those are also on Blackboard. I hope that's have been useful to you this year. So for real world connections, I connected it to technology and medicine. So for technology, looking at the pixelation, so the zoom or looking at a TV, the idea is still present here, especially if you connect it to the Art of Triangles project. You can read through that on your own. For medicine, it says many times patients ask other doctors for a second opinion, and when illnesses are complex, there can be multiple ways to treat it. So this goes back to the whole idea that there are multiple ways to solve a problem. I think that's something that is important to emphasize this unit and easy to emphasize this unit. All right, so getting into the objectives, we have day 1 is just looking at the triangle angle sum theorem and the triangle exterior angle sum theorem, looking at hinge theorem and classifying triangles. This is an extremely basic lesson, but it's kind of packed full of information, especially once you start looking at adjacent triangles like exit ticket number 3. I would just kind of gauge where your scholars are at with this lesson if you need to slow down or speed up, because this stuff is pretty basic. I have these little triangle pieces, or like these connectors, that I formed together to teach the hinge theorem. But even if you just take popsicle sticks or straws or rulers or whatever you have in your classroom and you teach the hinge theorem that way, that a smaller angle creates a smaller opposite side and a bigger angle creates a bigger opposite side, something hands-on like that and very visual will help the scholars learn the hinge theorem. Looking at day 2, we're talking about mid-segments, altitudes, and medians. This is a pretty big day too because the scholars can often get confused on all of these different lines, and it also requires them to know what a midpoint is, what the ticks mean, what a bisector is, what it means to be perpendicular. This builds on information that's very basic, so if your scholars aren't so confident with that basic material, I would do a couple fluency drills maybe before this day to get them ready on what those basic terms mean and how to apply them. Day 3, we start looking at congruent parts and corresponding parts, and how to calculate the lengths and measures of corresponding sides and angles. This is a good day to color code, I think, because you can color code parts with matching ticks or matching hooks, and it's very visual so that the scholars can see what matches and what does not. This lesson is really important for scholars to get down because if they don't understand the concept of corresponding parts, then teaching triangle congruence is going to be a big challenge for you, especially when you set up the congruent statements with congruent triangles or even similar triangles. So this is a really foundational lesson before you continue the rest of the unit. So also gauge your scholars with this. Moving down to day 4, we start to look at triangle congruence, specifically at side, 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 and side, angle, side. Day 5 looks at angle, side, angle, and angle, angle, side. And then I think day 6 is hypotenuse, leg. Yeah, hypotenuse, leg, and then practicing congruence statements all together. With this, if you feel that teaching your scholars all of the theorems at once would be better, then go ahead and do that. I think sometimes when we break up material, like looking at side, 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 angle, side the first day and then moving on the next day, it doesn't allow the scholars to really think through a correct answer, because they already know that because they're only learning 2 theorems that day, they have a 50-50 chance of getting it right. So I think when we throw them all together, then it challenges the scholars to really understand why the answer is what it is, and to understand the differences between the theorems. So essentially, you're teaching these theorems for 3 days. Divvy it up how you feel would be best for your scholars and what you feel most comfortable with. This is just how I have it in the unit plan. Day 7 is confirming triangle similarity using those postulates and applying properties of corresponding sides and angles in similar triangles to solve for missing parts. So one thing about this similarity is the symbol for similar is a lot different from the symbol from congruent, but the scholars sometimes see it as the same. So I would just emphasize the difference between what similar means and what congruent means, and how the symbols are different, because sometimes they see that similar symbol and they think it's congruent. So just emphasize that. Make sure they're well aware of what those symbols mean and what a proportion means, what a scale factor is. Scale factors are good to go over because we're going to expand on that in dilations for transformations, like the scale factors for dilations, and then looking at it in the 3D unit. What if your square is 2 times as big, so what's the area? Or what if your cylinder shrunk by 1/3, then what's the volume, etc. Okay, so scale factor is a big thing. What just happened? Okay, so day 8, you're looking at proportions and solving for missing sides and overlapping triangles. This goes into similarity as well. I would suggest either rewriting the triangles so that they're separate from each other and then color coding the similar sides, or somehow marking it up with colors or however you choose. But sometimes it's difficult for the scholars to see that 4, like here in number 1, 4 is not similar to 4. 4 is actually similar to 8, the entire side. They want to split it in half like this and think 4 compares to 4, but really 4 compares to 8. That's one common misconception. Or in number 2, they think that 14 compares to 7 instead of 14 comparing to that whole side. Day 9, you're simplifying and rationalizing radicals. That's a pretty big deal, and it's sometimes very difficult for scholars to understand. One way that I teach this is I ask them what number I can multiply any other number by and the value not change. So the answer is 1. I can multiply 2 by 1 and still get 2. Or I can multiply -1/3 by 1 and still get -1/3. So then once they get the answer 1, then I ask them, well, how many other ways can we write 1? Like, give me other possible ways to write 1. And so they say 1/1, and then they say 2/2, and then, etc. So that's a really good way to start introducing the fact that when you do this rationalization process, you're not changing the value of like this, the square root of 12 over the square root of 15. You're not changing that value, you're just changing the way it looks. Just like 2/2 is 1. The value is 1 no matter if you write 1 or you write 2/2. So that's something that the scholars sometimes get confused on. You'll also review for the Unit 3 test, midway test, and then on day 10 you'll take that test. It is on Blackboard for you to check it out. Then you start the second half of the unit. So day 11 is the Pythagorean theorem, Pythagorean triples. You have an investigation for that. Day 12 is looking at special right triangles. Special right triangles are killer sometimes. I've taught this in multiple different ways. I think the key is to do something that's maybe more hands-on and exciting and gets the kids moving, so that it's not just another class period where they're sitting down listening, doing independent practice, talking with a partner. Maybe it's more unique of a day, so try to plan a lesson that's more creative here. Then in day 13, you have special right triangle relationships and Pythagorean theorem, and you're applying them to word problems. you're upping the rigor here in day 13. And so if the scholars aren't ready for that, then maybe you can start day 13 by drawing a picture for them for each of their problems, and then start slowly weaning them off of your help, because these can be difficult. You could also do stations for day 13. I've done stations before for right triangles, and I think that's worked well. Day 14 is applying trig to solve for side lengths in right triangles, and day 15 is applying trig to solve for angle measures. So we have trig and then inverse trig. Again, if you want to combine those, so the scholars need to know exactly when to use what process, then go ahead. You have 2 days to teach trig. By day 16, you're solving for side lengths and angle measures in right triangles using trig, ratios, angles of elevation and depression given a word problem or diagram. Yikes. So that one, essentially, you need to teach angle of depression and angle of elevation, and then apply trig to word problems. It's kind of a long objective just to describe applying trig to word problems within the context of angle of depression and elevation, instead of just saying an angle. Day 7, going back to day 16, this is when I built in that finding the height of your classroom using trig project. If you feel that another day is best for this project, then feel free to make that call. That project also has an extension, so if you have time, if you're ahead or have extra time or whatever, then this project also has a part where you can continue from finding the length or the height of your classroom. You can go outside and find the height of your building, or go in the hallway, find the height of the hallway, however you want. So this is has a built-in extension if you feel free to take it, if you want to take it. Day 17 is interpreting word problems with special right triangle relationships. So kind of combining Pythagorean theorem, special right, and trig all together with word problems. This is a day to really hit hard so that they're more prepped for the CA and for really the ACT, things that are tests that are more rigorous. Day 18 is your only flex day for reviewing for CA2, and then it should be winter break. I'm just going to talk these the little triangle pieces that I had mentioned. I included the link for Amazon. I love those. They're called like anglegs. Looks like, I don't know how to say it. I just call them triangle pieces. But I included the link here in case you want to purchase them. I highly encourage it because I love them and I use them all year long. Because they're color coded, they're all measured. You can unsnap them and snap them, and the kids really like that noise, which is silly, but like if it gets the kids engaged, then it gets them engaged. Then you guys can figure this out or fill this out on your own. All right, so that wraps up the virtual unit preview. If you have any questions, then please reach out. I'm always here to help you. We can meet together and plan however you want so that this triangle unit is as successful as it can be.